Okay, students, welcome back. As I promised last time, we will be discussing some ideas for the projects or some practical work. So I have got over here lots of things with me related to machine learning and Python. But there is one problem that most of these things they are complex, and normally all of them they require that you should have some experience and knowledge in data wrangling or data handling. You should be able to modify the table columns or values which come in different forms. So data is not always so simple that you just run the model.fit command to fit the data on the training set. So here there are many ideas. So I will give you these ideas. You can explore these ideas for your project. One best source that I have worked with was Kaggle. So on the Kaggle you will see examples like for the car insurance. That's a typical data we have worked in the class. Another one was very interesting. It will be but difficult. The data handling is difficult. It's the data set related to the cats and dogs images. So there are lots of images given over there for cats and dogs, and those images are treated as the input features. The pixels of those images are treated as input features, and then the model is trained to identify between any image that is coming from anywhere, a new image, try to identify it as a cat or a dog. So it's an interesting idea. Another one was this was about that quite serious problem. It was a competition where it was given a data set related to the New York taxis, that how those taxis so taxis they run over there by big companies. So those companies they shared the data that how much time their taxis they take for an average ride from any one part of the city to another part of the city. And the task given was much more challenging. The task was that for any future ride based on the time of the day and the place in the city, it was the task to predict how much time this taxi ride will take. So it was quite a challenging task. So I personally I competed at that time in it, but I wasn't so good at that time, and I ended I think in 400 something position out of those 5,000 I think. I don't remember 2,000 or 5,000 overall competitors. Then there is another challenge. This one is also very interesting. It's the Titanic dataset. All of you know that what Titanic was. Titanic was a big passenger ship that was carrying people, I think, from UK to USA, and it was there was a big disaster. It was broken down in the middle of the sea, and most of the people they died. But there were a lot of people who survived also. So this data set is also interesting, and you see over here the training and test data set. It is given already on the Kaggle website, and they launched a competition, and over there the data has got these different entries. So you see over here it's from here you see maybe it's a simple. So passenger ID, you can guess. Passenger, did he or she survived or not? So it's a boolean value, true false. Passenger class, so maybe the class of the passenger was related if the passenger is a rich passenger or a poor passenger. So these are the three classes I think there were. And then passenger name, there were ideas on the Kaggle. Many people they tried to get some information from the name column also, but maybe it will be really challenging for you people, because you people never have done these things, how to handle data in Python. So it requires that there should be at least one course before machine learning somewhere. And then there is another column related to the gender, male or female, and then the age, which can show that maybe the person was a child or middle aged or an old person. And then there were some other features, I don't remember, SIBSP. I think this was the boarding place. Many people boarded from different places, so there was something related to this. I don't remember this part. Ticket number, maybe it can be used or not, I don't know. And fare is like the money they paid for this. So mostly you see people who were in the first class, they paid a lot of money. So at that time, like $71, whereas the people for the lower class, third class, they paid a fraction of that amount, almost 1/10 of that amount, $7. Okay, so this may be related to the survival, maybe or maybe not, we don't know. And then there is the cabin numbers, and then there is embarking. I think this is the embarked from where they get onto the ship. So S or C, there are some codes. I don't remember, but you can get easily information from the net. So a lot of things have to be done in this code. It's not so simple. So if you run the count on these sets, the training and test data sets, here you will see that lots of entries are missing. For example, age, it's not written for everyone, and especially the cabin number, it's not written for a lot of them. So it's challenging. You have to do something, because remember, the machine learning will only work when all the columns, they have some value. Either it's maybe you can put a mean value or a zero, or you can even remove that column at that row totally. So it depends on you, but and in the end, the machine learning algorithm will only work if all the columns, they have a valid entry. If there is an invalid entry, it will not work. So here are some of the techniques we did not discuss here, related to Python programming. So for example, you see over here, there is a function to use. So because it is a totally, it's a quite vast thing, we can't cover it here, like how to deal with the pandas. So here it is given, you see there is a method called fill NA. Fill NA is not NA, I think it was not applicable, or not a number. So NA, what it says is that if there is a invalid position inside the column somewhere, means that it does not contain data, then put for this column, put the S. Similarly, if there is some missing value in the age column, put it or fill it with the median value. So like this, there are many things that are done for the missing values. Missing value is a very serious problem. Practically, remember, it is a general rule that 80% of the time in a real machine learning job, it is spent on data manipulation and data cleaning. Only 20% of the job is done on real machine learning and model tuning. So to tune the model, to tweak these parameters of the model, these are important, but they take less time as compared to this initial stages, because these are more cumbersome. So here you see then the columns, they are converted from strings, for example, to booleans. Some of columns like gender, it was in strings, so it has to be converted. Similarly, the embarked column also was changed from S, C and Q to some numbers, because remember, machine learning will only work on the data that is a quantity, that is in the quantity form, not strings. Machine learning will never work on strings. So remember, important exam question, machine learning, the input to the machine learning, it cannot be string. It can be number, it can be float, but it cannot be string. Not directly. Indirect methods, yes. Okay. So this was it, and then there is lots more of these things, and then finally model training occurs. Over here the model training is done using something. So they have used a random forest. This is an algorithm. There is another algorithm, decision tree classifier. So these are different methods. Each method has its own function or algorithm implemented. You just have to call it. And then there is another one over here, which is the deep learning. So multi-layer perceptron model, it is basically the neural networks. So neural network is used over here, but we didn't do it in this much details. And then the model is trained. Neural networks are trained like this. And finally the evaluation is done, and I don't know where is the result. So this is the summary, how the things are done. So this is not what we are going to do. Here is another one. So this was Kaggle. There is another one, another competition on the Kaggle. It's Zillow. Zillow is about the housing prices. You can check it over there, but we have already done some sort of housing price prediction in our class. So there are some more based on some other competitions. On the data camp there are some projects given, and we will go to some basic. So in the basic you have related to the iris dataset. We will cover over here today the NMIST. So NMIST, I have different versions. One already with me was implemented in TensorFlow. So TensorFlow is for neural networks. We didn't cover it, so I downloaded something from the net. So it is implemented in logistic regression that you already know. So here it is. So I will provide it to you. Just load it, and then you go through it. Simple. This dataset is given inside the scikit-learn. So here you have got, for example, matplotlib in line. You already know. And we load the dataset. From the datasets we load this digits dataset, load underscore digits. So you load it, and then what you do is try to see in the digits dataset. Now this thing is interesting. Before you go next, so let's see the digits dataset. You must explore it, what it is. So here it is. It is something called in Python as a dictionary. So it contains lots of data, but in separate groups. So normally each group has its name written on the front. This is a special style. It's called in Python called as dictionary. Okay. So you don't need to know these details. Only interesting thing for you people is that the data in the digits variable, the data is given here, digits.data. So it will contain lots of arrays, one array for one digit. Okay. And so remember what task we want to do over here. We basically want over here that the digits, we train our model on the handwritten digits. The example I gave in the class. Okay, I showed to you. That was done in 2005, I think, by Jean Lecoq. So here it is given the data, and then there is a target over here given to you. Okay, so target for each data value, that is, this is the X and this is the Y value. So for example, the first data over here, this one, it is basically representing 0. So here we have got lots of output variables, not only 0 or 1. So we have 9 digits from 0, or 10 digits from 0 until 9. Okay. So this is it. If you want to see, for example, particular So here it is data. If you want to load only one value, the first one maybe, it is like this. So it is this over here is a complete data. It's representing one small image which represents one data. So like this we will go next below. So here you will see this is the shape. So to print, to show over there are 1797 images in total. Okay, and all these images, they are 8 by 8 images. So here this array contains 64 values, 64 pixel values. Okay, so when we load, it will show over here. So the digits dot data is the x value and digits dot target is the y value. I hope it's simple. Here it is, they have plotted some of these values, 5 values. Okay, so 5 values they have plotted. This is quite confusing. Just to make it simple, just use the computer vision function. Those who haven't taken this course, over there you can call the PLT function called IMShow. So IMShow will show the image, the data as an image. So here you will call the data, for example, data 0. You can choose any other value, maybe ninth. What is the ninth value? If you want to show it as an image, first you have to reshape it, because remember, now over here it is just like an array, a full array, 64 digits, 64 values as a single one-dimensional array. You cannot show it like this. So first you have to convert it into a matrix. Remember, images are basically matrices. So it is converted by the reshape command, reshape 8,8, and then you can just show it. So it is basically, this value is 9. Okay, maybe if you are not comfortable, maybe it's not showing good, then you can, I think you can reduce the size. So let's try fig size and make it a small size. Maybe then you can even more smaller. So the image is not clear because of its bigger dimension. Okay, so I don't know, choose one by one. Still it's maybe its number of pixels are so low that you cannot get the image easily. Okay, 2 by 2 is, I think, enough. So this is it. So every row represents one digit. Okay, and these are handwritten digits. Okay, that's what we want to train our model for. So here is the familiar command you already know, train test split. So we give it two sets of values, data and so input x and target y, and then we decide that we want to split it on 25%. So test set will be 25% and 75% for training. Then we, so let me run it also. Then we call the what you say, from the linear model we call the logistic regression. So this is a classification problem. You instantiate the logistic regression and then you fit the training data onto it. Okay, sometimes you will see the warnings. Warnings are just, most of them are future warnings, that in the future they are going to remove some function or some property, so be careful. Okay, so this is done, and then the task comes is that you try to predict the value. Okay, so in the test set you try to predict the value from 0 until 10. 11 values you want to predict, so it's given, and then you make the prediction on the entire data set. How you will measure this prediction? You will try to compare it with the, because remember you already have the test data, because you split it, you already know the results. Okay, you split it from the original trending data, so you already know where it can be. So here it is, let's say x underscore test, the first 10 values 0 until 10, it is this. Okay, so too much. So let's say first maybe two values. Okay, and then I would like to see what are these two values, so you can use y underscore test. Okay, so here you will say again 0 to 2. So it tells you that the first array over here, it is the digit 2 and the second array is digit number 8. So what was predicted by us over algorithm? Yes, it also predicted same 2 and 8. So for rest of them and for the whole data set, how much was the performance? For this we will use the score function. So here it is, logistic regression dot score, and we provide it the x test and the y test. So it will run the algorithm itself on this function and compare the y test, the output already that is with us. It will compare. So it compares and it gives us that the accuracy of this logistic regression model is 95%. 95 is good, but it can be improved. Okay. Then there are more details. We will not go to that side. Confusion matrices is a huge science, very big science. And then there are some other things, a lot of things. We will not do that. It's too much for you people. Okay, so this is it. This is one example for your project. I suggest you people go to Kaggle, go to online forums, try to find out something and try to do something. For example, I can give you one idea. Try to search some data set for Arabic digits. So these digits you see over here, I don't know, I have no idea if there is such data set or not, or I don't know. I'm just giving a suggestion that these are the numbers you see over here. Try to get the ones for the other digits that are used over here. By the way, interesting thing is that these digits that you see over here, basically they are called Arabic digits. First time I got to know this thing in France, and my French professor told me, and I was surprised and little ashamed that I don't know this thing. He told me this thing, that these digits are called Arabic digits because basically they came from the ancient Middle Ages. Arabs used to have these digits. They use these digits that are now in English. Okay, and the ones that the Arab countries are using now, these digits, this is a huge history, but they came mostly from Persia, Iran. And why they came from there, and also in Urdu also, it's the same digit script with little bit of changes. They came from there because Iran was the place that first started to use the printing press, the printing facility in a big scale. So printing, the books were printed, the newspapers were printed, many things. So the numbers from there, especially on the books, they went and they spread on all these areas. Okay, so that was just for your knowledge. Here I gave you idea. Just try to use the other digits that are used in Oman and think if you can do something. It will be a good project if you get the data set from somewhere and then you write some digits at your place yourself, or maybe ask all your family members to write some digits, write all the digits from 0 to 9 in their handwriting, and then you clip it, you digitize it, you clip it, and then you give it to the algorithm as 8 by 8 matrix, and then you try to see what will be the result. That will be interesting. So do something like this. Your project should be something like this. It should be a Jupyter notebook. You have to explain all the steps and it should be a meaningful project. But before you start working on the project, on this mini project, make sure you discuss with me your idea. Is it acceptable or not? So good luck to you all. I hope it was informative. I will share this on the SharePoint. See you then.